about using inverse trig functions. And this is what they look like. Sine inverse, sine raised to the negative first. It's not actually an exponent. It's just showing that it's the inverse of the sine function. And when I say inverse, I mean addition and subtraction, or multiplication and division. Those are inverses of each other. Squaring something and square rooting that thing are inverses of each other because they cancel each other out. That's exactly what sine inverse, cosine inverse, and tangent accomplish. They cancel out the sine function, and really it's to solve an equation. That's what we imagine when you're doing x plus 2 equals 4. When you subtract 2 on both sides, you're using an inverse function to solve that equation. Just as a reminder, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so we're still looking for that same information. What are we given, and what two sides, and what trig function relates those two sides, What trig function will relate these two sides? So across from that, we see 5, that's our opposite. We also see that we have the side that's across from the right angle, so that's our hypotenuse. So we want to think about which trig function relates the opposite and the hypotenuse. Well, that is sine. So sine of theta, I don't know that yet, equals, I do know the ratio, that's 5 over 13. So here you're just going to plug in the opposite side. We're given the two side lengths, and we're going to work backwards to solve for that theta. So this is where we're going to use sine inverse. You want to imagine sine inverse of both sides. Sine inverse and sine cancel each other out. That leaves us with just theta. On this side, we have to do sine inverse of 5 over 13. That is just directly in the calculator, sine inverse. You can type it with an exponent, or there's also the function sine inverse here. 5 over 13. And that is giving us an angle measurement. That's saying that this angle is 22.62 degrees. Same kind of thing here. We have this angle. We know the side that's opposite, and we know the side that's the adjacent side. So opposite and adjacent are related by tangent. So tangent of theta equals the opposite over the adjacent, which is 6 over 8. So theta equals tan inverse of 6 over 8. You could also simplify, You're also able to simplify this fraction, because any fraction that simplifies that way, 3 over 4, 6 over 8, 0.75, any of those will have the same value. That's how we started off this unit, talking about similar right triangles. It doesn't matter how big these sides get. As long as it's similar to this triangle, we could double that and make it 12 out of 16. It's going to have that same angle measurement here. So you could type 0.75, you could type 3/4, you could type 6 over 8. All of that's going to be the same. It's 36.87 degrees. All right, here we're given the side that's adjacent and the side that is the hypotenuse. So adjacent and hypotenuse are related by cosine. So cosine of theta is 5 over 5 radical 2. So we're going to do cosine inverse of 5 over 5 radical 2. That is 45 degrees. Alright, here we're looking for this angle theta. Actually, we have any choice we want because we're given all three sides here. In that case, I always just like to use tangent. I'm not really sure why. I just prefer to use tangent, so I'm going to use tangent. Tangent of theta is the opposite over the adjacent side, so that is 3 over 1. So we can do tan inverse of 3 over 1. Like I said before, we can simplify that. We really don't need the 1 on the bottom. We're just going to do tan inverse that is 71.57 degrees. Actually, what I like to do in the calculator when I'm doing a bunch of these problems is just have sine inverse ready, cosine inverse ready, and tan inverse ready. And then based on the relationship that you're using, you just end up changing whatever's inside the parentheses. All right, so we know the one opposite, we know the one that's adjacent. Opposite and adjacent are related by tangent. So I'm going to do tan inverse of 4 over 4, which is 45 degrees. And that should really make sense. This is an isosceles triangle. That's got to be 45. That's got to be 45 too. Same case here. Those are both 45 degrees. This is actually an isosceles triangle. The last one, we're looking for this angle theta. We're given the adjacent side, the one that's next to it, and then the hypotenuse. So we're given adjacent and hypotenuse. That is cosine. So it's going to be cosine of the adjacent over the hypotenuse, cosine inverse, really, of adjacent over hypotenuse. It's 10 over 18. That is 56.25 degrees. So trig functions, when we're using just the straightforward trig functions and we're given the angle, we're using those to find side lengths. Inverse trig functions are used to find angle measurements.